Welcome back to the drive-thru. Today we got some questions from section 2.8 about linear and exponential functions and how to find our domain for these. So first, in number 4, we want to figure out what all of these different letters mean. So when we have R, this capital R in choice A, this is going to be all of your real numbers. So that just means anything that's not imaginary. So any number as long as it doesn't include that imaginary number I. So that can be positive numbers, negative numbers, fractions, pi, anything like that. W is going to be whole numbers. So this is going to include 0, 1, 2, and then we're going to keep counting up like that. So 0 and any of the normal counting numbers. Next we got Z. This is our integers. So this is all of our whole numbers, but we're also going to include negatives. So we have -2, -1, 0, 1, 2, and then we're going to keep going. We can get numbers bigger than that, smaller than that. We want all of our counting numbers, but both positives and negatives. Then we got N. These are our natural numbers. So these are the normal counting numbers. So same as the whole numbers, except we're not including 0 anymore. So we have 1, 2, 3, and we keep counting up like that. Then we got our last one here. Q is our rational numbers. So these are all numbers that can be written as fractions. So that includes 1/2, 3/4, any fraction like that. They can be negative too, so I can say -1/2. And this also includes numbers like all of our integers, because we can say 3 and write that as a fraction by doing 3/1. So that includes all of our integers plus all fractions. So if we're looking at number 4, we want to know which can be modeled with a continuous function. So continuous means we should be able to plug any number into a function and get an output. If we're looking at our integers, our natural numbers, or our whole numbers, that's not going to work because we can only plug certain numbers in there. We can only plug, say, 1, 2, and 3 into those numbers. We can't plug in those that 1/2, 3/4 like that. So we're going to get rid of those answer choices and pick A, because that we can plug in any number we want, and we could create a smooth graph. So some graph, maybe it looks like that. We can plug in any number there. Okay, then in number 5, which is the mathematical way to represent the natural numbers. So like we just went through, natural numbers are represented by N, so we get choice D. Now we want to figure out some actual equations for this. So which one would be a continuous exponential model? If we're looking for exponential, we know that's a geometric sequence. So I can start by just getting rid of choice C, because that would be a y equals mx plus b form, and we know that would be an arithmetic. We don't want that. I am also going to get rid of choice D, because that is a recursive formula for an arithmetic, because we see we have this -5, which would be if we were subtracting 5 for every point in our table. So we're left with A and B here. For this, we have A is our recursive formula. But if you think about how you typically use your recursive formulas, you're going to plug in x equals 1, x equals 2, x equals 3, and make a table that way. But that's only using certain numbers. If we plugged in a 1/2 there, we're not going to be able to find an answer. So that one is not going to be continuous, which leaves us with choice B. Number 7 here is similar, but now we want a continuous linear model. So I'm going to go ahead and start by getting rid of choice B and choice A, because those are both for geometric ones, and we need an arithmetic sequence. So we left with choices C and D. Again, our recursive formula is only going to let us put in numbers like 1, 2, 3, 4. So that one is not going to be continuous. We need choice C. Then our last problem, which domain choice would be most appropriate for an arithmetic or geometric sequence? For sequences, if you think about how you've been doing your tables, you've only been having numbers like 0, 1, 2, 3, 4. So we can get rid of the reals, because we typically don't have these half points, and get rid of Q, again, because we typically don't have these half points. Then we're left with C and D. So the difference between these two is that in D, our natural numbers are going to be 1, 2, 3, 4, and keep counting up like that. But C is going to be the integers, and then also integers greater than 0. So that's going to be 0, 1, 2, 3, 4. So the difference between these two is that C includes 0, but D doesn't. When we're working with sequences, we're usually dealing with first term, second term, third term. So I'm going to say D would be more appropriate for that, because that's more commonly what you're going to use.